Alright guys, this is Dilutions Part 1. So basically the purpose of this particular lecture is to, as the name suggests, show you how to do dilutions and give you an idea of what you're going to have to do when you're in the lab. So dilutions are a very practical thing. It's something you will be doing on the job frequently. They're not hard, they're nothing to be afraid of. It's an easy thing to do, but in the beginning when people are learning them, they typically have trouble. So let's go over the most important things to know about dilution. So dilution factors can basically be any ratio: 1/2, 1/3, 1/4, 1/6, 1/100th, 1/1000th. You're probably not going to be using 1/1000th or even 1/100th, but the point is they can be whatever. Now the key to understanding dilutions is understanding what a dilution factor represents. So we'll start with 1/2. So the top number represents the thing you're diluting. That's going to be patient specimen. In your case, as a medical lab scientist. The bottom number is going to be patient specimen plus diluting fluid. And that doesn't matter what your dilution factor is, so they're always going to equal that. So in the beginning, here's what I recommend you do. So let's say you're working with a dilution factor of 1/4. Well, the key to remembering what I'm talking about here, the patient specimen plus diluting fluid at the bottom, is this. So if we're to break it up to represent that, we have the one at the top, which is the patient specimen, and we have to add that back into the bottom, because again, the bottom is patient specimen plus diluting fluid. So let's add it back in. Now, for there to be equality here, right? What number has to be over here? 3, right? Because it has to equal 4 at the bottom for this ratio to be maintained. So what does this mean? This means 1 part patient specimen at the top, and then at the bottom 1 part patient specimen plus 3 parts diluting fluid. So why is that? Well, the bottom number represents the total solution, right? Not diluting fluid. That's the common mistake. People think this bottom number represents how much diluting fluid is added. It does not. It's diluting fluid plus the thing you're diluting, which is patient specimen. A visual way to understand this would be in this fake test tube, or imaginary test tube. We have diluting fluid, right? And then in this one we have patient specimen, which is a horrible drawing. But so we have patient specimen here. We want to dilute the patient specimen. So we're going to pull diluting fluid out of this tube, add it into this tube. Now we have a portion of diluting fluid. So it's this combination of diluting fluid and patient specimen that represents the bottom here, right? And over here. That's the bottom number, patient specimen plus diluting fluid. And that's a visual way to remember that. So why is this so important? Well, whenever you go to do dilutions, let's say that you need to do a 1/2 dilution, and you have 200 microliters of patient specimen, right? So the question is, how much diluting fluid do you need to add to do a 1/2 dilution? A common mistake people will make is they'll say, "Oh, I need to just multiply by 2." They'll be like, "Oh, okay, that's easy. 200 microliters patient specimen times 2 equals 400 microliters." And they're like, "Oh, okay, that's how much diluting fluid I need to add." And they'll be like, "Oh, am I right?" They'll be like, "Okay, 200 microliters over 400." And they'll be like, "Okay, 1/2. Yeah, I did it right." Well, no, they actually didn't. And here's why. So if you're doing a 1/2 dilution and you've got 200 microliters of patient specimen, right? Here he multiplied out, or our imaginary student said, "Oh, I need 200 microliters, so I need 400 microliters of diluting fluid." So he said, "Okay, I need 400 microliters of diluting fluid." That's patient specimen. So if that's the case, then here's what he did. He said, "Okay, 200 microliters patient specimen divided by 200 microliters, because again, we have to add back in, because the bottom number is patient specimen plus diluting fluid, plus 400 microliters of diluting fluid. which is going to equal 200 microliters over 600, which is going to equal 1/3, not 1/2, which would mean this imaginary student did a 1/3 dilution, not a 1/2. So how do you not make this error? Well, you follow the steps I showed you. You say, oh, okay, I'm going to do a 1/2 dilution. We've got 200 microliters patient specimen. So what I want you to do, especially when you're new, is rewrite out your dilution factor. Right? Do this. 1/2 equals 1 over 1. Because this is going to remind you, I got to put my patient specimen at the bottom. Over 1. Diluting fluid. Okay? So, this is the number you multiply by. 200. When you're trying to figure out how much diluting fluid you need to add. Right? So, if we have 200 microliters of patient specimen recommending 1 part, then we got to multiply by this to figure out how much diluting fluid. So 200 microliters times 1 equals 200 microliters. And so if we do that math, we say, okay, 200 microliters divided by 200 microliters plus 200 microliters equals 200 over 400 equals 1/2. We're correct. That's the dilution factor we needed. So I'll do one more, and then I'm going to go a little bit more in depth on the algebra of this so you understand this better. Because I'm starting off showing you basically kind of the quick way, but to make this clear, let's do a different dilution factor. So let's say you want to do we'll say 1/6 dilution, and you got 200 microliters of patient specimen. How much diluting fluid? Well, what would we do here? Well, this is what I showed you to do. Break it up. 1/6 dilution factor is going to be equal to what? 1. We got to put that 1 at the bottom because patient specimen's there. Plus what? 5. Has to be 5 because these have to be equal. So 1 over 1 plus 5 is 6, right? Or 1 over 6. So it's this number what you need to multiply by to figure out how much diluting fluid. And when I say multiply by, multiply the amount of patient specimen you're starting with. So 200 microliters times 5 equals 1,000 microliters. Let's check our work. So 200 microliters divided by 200 microliters plus goodness, what I say, 1,000 microliters equals 200 over 1,200, which is going to be 1/6, which is what we want. That's correct. So guys, this is part 1 of dilutions. Part 2 is going to go a little bit more in depth with the algebra, just to make sure you have a better understanding of it, and then we'll reflect back to the fast method. And once we do all that, this will be easy. You're not going to have to do a bunch of math, especially when you're on the job. You just I'm going to make it really clear and show you the quick way, or the even faster way. So that's going to wrap it up for this video.